systems of linear inequalities. So a system of linear inequalities is two or more linear inequalities solved together. So we did linear inequalities last time, and now we're going to be putting two or more of them, specifically two in Algebra 1, together on the same graph. And what does it mean to solve them together? To solve them together means we're going to look for something called the feasible region. Feasible, fancy word for like possible. So the feasible region is the collection of all points that satisfy or make true all of the inequalities or equations. All right, so let's look at some steps for how we would graph a system of linear inequalities. So step one is to graph the first inequality and use arrows or lightly shade its feasible region. So I'm going to show you what that means. So we're going to go ahead and I'm going to look at the first inequality, y is less than or equal to negative 4x plus 3. All right, so start with the y-intercept at 3. I'm going to zoom in here a little bit, and we're going to go down 4 and over 1, down 4 and over 1. I can go up 4 and over 1 here as well. All right, because it is a less than or equal to, we're connecting with a solid line. Now, if it was just one inequality, we would start shading right away. And some people do like to lightly shade at this point. But a method that I've never seen anyone else do, but I use arrows to do this kind of temporary step. So it says it's y is less than or equal to negative 4x plus 3. We can certainly use a test point like 0, 0. But when they're in a slope-intercept form, if you see y is less than, some people can't see this, but we're looking for where the y values are less than this line. So you can kind of think of it as, okay, here are the y values here and up here. Where are the lower y values? Well, certainly they're in this section down here. So this graph would be shaded in this direction. So I'm going to put 3 arrows. Again, if you had tested 0, 0, you would have found 0, 0 is true, and you could go about it that way. All right. Don't have to change colors, but it is nice to do so if you have the ability. So y is less than 2x minus 3 is our second inequality. So down to negative 3 for the y-intercept, and we're going to go up 2 and over 3. Right there we intersect. Up 2, should I say up 2 over 3? Up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. We can go down as well. Great. Now this one, because it's just a less than, is going to be a dashed line, dotted line. Great. So now this one, y is less than again. So again, we're going to be below this line, less than below the line. So I'm going to put a few arrows here. So what we're ultimately now looking at is where would both areas be shaded? Where would they overlap? That's going to be our feasible region. So really we've created 4 regions, a section up there, a section to the right, a section at the bottom, and a section over here. You certainly don't have to label them A, B, C, D, but to kind of get some clarity here. So where are the arrows both pointing at? In A, no arrows are pointing. See that you can see the red and the blue lines are pointing away from section A. In section B, the red line is pointing towards it, but the blue line is pointing away. D, the blue line is pointing towards it, and the red line is pointing away. But if we look at C, C is where both red and blue lines are pointing. So that is where we're going to shade. So I'm going to go ahead and just shade that section in there. That is our feasible region. That is the solution to the system of inequalities, of linear inequalities. All right, so if I come back over here, we're going to, you might say, darkly shade. If you are, sometimes I've seen people, they will do a similar thing where they will go, instead of shading that region, what they will do is they will, let's go ahead and color coordinate everything. They'll shade, okay, over here, and then they'll shade the other one over here, and it kind of makes region C down here the darkest region. So I would come back and say, okay, well, let's make sure it's definitely doubly clear that this is the darkest region, so I'm going to like extra darken in this. But to me, that looks more messy and confusing, so I prefer to just have one region shaded. So that is our final answer. Okay, let's look at some additional examples. We're going to go ahead and look at number 4. 4 is a sneaky case. So when we go ahead and graph the first inequality, we start down 3, and we go down 4 and to the right 1, up 4 into the left one, up 4 into the left one, and it is a solid line. Okay, and since we have a less than, it is below the line. So arrows that way. Okay, we'll shade the other line. We start up 2, and we're going down 4 over 1, down 4 over 1, up 4 left 1. And again, we have a solid line. Now, some of you might have right away noticed that these lines are parallel. Now, this time it says greater than, so that means we're going to be going this way. So this one actually only made 3 regions. So it made a region A over here, a region B in the middle between the lines, and a region C. So in which of these regions are both of the lines pointing towards? Well, A, blue is pointing to, but B isn't. Red isn't. B, neither is pointing towards, and C, only the red is pointing towards. So there's no region where they're both pointing, so this one is no solution. Oh, tricky. So no place where there should be any shading. Okay, so both of those examples were in slope-intercept form, but let's go ahead and look at an example where we have a graph that is, or inequalities that are in standard form. All right, so for this set here, number 8, the inequalities are written in standard form. You could convert them to slope-intercept form and graph there, but I'm going to show how to graph them from standard form. So like we would have done in the past, I'm going to find the intercepts. So if x is 0 here, y would be 1. And if y is 0, x would be -2. All right, keep our color coordination here. If x is 0 here, y would be 3. And if y is 0, x would be 6. Okay, so let's go ahead and graph those. So 0, 1 is simply up 1, -2, 0 over here. And this is a greater than or equal to, so we have a solid line here. Now, the trick we had used last time about the greater than being above the line and the less than meaning below the line doesn't really work for standard form. So we really have to use a test point. So if I plugged in 0, 0, 0 minus 0 is greater than or equal to -2, is that true or false? 0 is greater than -2. Yep, that's true. So the origin is true. So we're going to be shading this direction. Great. For our other line, let's go ahead and plot its intercepts. 0, 3 is there, and 6, 0 there. This line also solid. All right, let's do a test point for it. 0 plus 0 is greater than or equal to 6. Is that true? Nope, that is false. So it's not going to be towards the origin. It's going to be up this way. Okay, so hopefully you can see which region we're going to be shading in. It is going to be this region that's off to the right. That's where both of our arrows are pointing. And so this is the feasible region. It's what we're looking to. It is the solution to a system of linear inequalities. Thanks for watching, everyone. See you next time.